Okay, good morning, Math 8. Hopefully this recording is a little bit easier to see. I know the last one there were some issues with it being a little bit too far zoomed out, so let me know if there's ever a time when you can't read what's on the screen, or Mr. Roboto, that video is kind of off or we couldn't really see it. Just let me know, because sometimes I don't see it the way you guys see it. Okay, so we're going to look at one more Pythagorean theorem lesson today to close out the week and sort of close out our unit. And that's combining the Pythagorean theorem with our coordinate plane. So we're just going to start off by saying, we're going to order the following pairs of coordinates from closest together to farthest apart. So like our A and B the closest together, our C and D the closest together, E and F, G and H. Which pair is the closest together and which pair is the farthest apart? So think about looking at it in terms of the ordered pairs. Like, how would you tell distance from the ordered pairs? And then look on the graph. Which ones are the closest, which ones are farthest apart? The graph should be easy. And then look and see, how could you tell from looking at the ordered pairs which ones are closest and which ones are farthest apart? So pause it and take a minute to try that. So obviously, by looking at the graph, you can see E and F are the closest pair together. The black pair is the closest. All right, and you also be able to tell how far apart are they. We'll get to that in later, but think about how far apart they are. Let's see, the next closest, B and A. Well, C and D is definitely closer than G and H, so it's not G and H. So B and A and C and D. So I'm gonna say that B and A are the next closest. And here's why, because B and A are only 1, 2, 3 boxes apart, whereas C and D are 1, 2, 3, 4 boxes apart. So third closest, and they're 4 apart. And then G and H are much farther apart. And I actually have totally the wrong ordered pairs for G and H. And I hope none of the rest of them are wrong either, because that'd be awkward. Okay, G is negative 3, 0, and H is 2, 0. Wow, awkward. Okay, I'm going to fix that. Okay, I think the rest of them are right, though. Yeah, so let's look at our ordered pairs and see if we can figure out how we could tell without even looking at the graph how far apart these points are. So let's look at E and F. E and F are only 1 apart. Alright, so E and F, they're only 1 apart. And I can tell on the graph because there's 1 box between them. There's 1 little unit line between them. And if I look at my ordered pair, E is at negative 1, 5, and F is at negative 1, 6. So the Y value here is 1 higher. So the Y value of F is 1 higher than E, and the X is the same. So it's vertically up 1 unit. And then I can look at the same thing for C. So for C, here's the third closest, negative 3, 2, and 1, 2. The X values are different by 4, and the Y is the same. And the important part here is really that the Y is the same, because we'll look at points that maybe nothing's the same, and we'll say, well, we don't know how far apart they are yet because one of the distances, because we're moving on X and on Y, so it doesn't really, if I move like from D to A, if I go up 2 and right 1, that's not a distance of 3, because you can see this distance from D to A is much shorter than this distance from D up to this imaginary point here. All right. So we're really looking at the difference in the X and the Y coordinates as giving us distance here. All right, so let's look at it for the last couple. So A, let's see. For A, we can see that A and B, 2, 4, and 2, 7. So the X is the same, but the Y is different. So the Y value is different by 3, because 7 minus 4 is 3. to make it easy to understand. So the y value is different by 3 because 7 minus 4 is 3, and the x values are the same. And for g, we have, oh dear, we have the x values are different by 5 because 2 minus negative 3 equals 5. All right, and the y value is the same. So the distance is quite simple if the y value is the same, or if the x value is the same. If something holds to be the same, our distance job is easy. But we're going to look at today what happens when distance is not necessarily only in one direction, like if you travel up and to the side, or if you're traveling north and south. I'm going to throw that on the previous page. Perfect. All right, so like we're going to look at like connecting A and D, and what do we do in that case? All right, so let's look at the next part. So let's look at J and K. So how far apart would J and K be at 4, 5, and 7, 6? If that's where they were, how far apart would they be? So we'll come back to that later, and just so I remember we'll come back to that later, I'm going to put this at the end of our video. Put that there. Okay. So we'll delete that for now. So now, below we have 3 lines. We have a red dashed line, a blue dotted line, and a pink solid line. All right, and we have them sort of connected between 3 ordered pairs. So I'm going to take a minute and think about what would the side length of that red line be, and what would the side length of that blue dotted line be, and have we been learning something for the past week or two to help us figure out what the length of that pink line should be? Notice that's a right triangle. All right, so let's find the red and the blue sides and see if we can use that to find the pink side. So my red side, let's see, the red dashed line is vertical. It goes from negative 14, negative 3 to negative 14, 9. So the x value is same. So the length is 9 minus negative 3, which is 12. So the red dashed line is 12 units. My blue dotted line, down the bottom, notice my y values are the same. I have a negative 3 for both my y values, my second values. So since my y value is the same, the length is the difference in x values. Just like above, the length up here was the difference in the y values. Down here, the length is distance in x values. So we would do 16 minus negative 14. And the order you subtract doesn't really matter because you would get 30 in this case. If you did the other order, you would get negative 30. Just make sure you're using a calculator to double check your math. Don't say that distance is 2. That distance is obviously not 2 because it's huge. 2 would be this big, from 0 to 2. Use your sense to say that this is a large distance, and it has to be bigger than this one. 16 minus negative 14 is 30. Okay, so my side length here is 30 units. So now, the 3 lines together form the shape of a right triangle with a pink line as the hypotenuse. So we want to find the hypotenuse length. So I'm going to say that, take me a while. All right, a squared plus b squared gets me c squared. A squared plus, then blue, b squared equals, and now pink, c squared. And now I know a and b, so I just have to use that to solve for c. So it's really just the same thing, but on a grid. And I find out a lot of students actually tend to like the grid at least as much as they like non-grid problems because they're already familiar with it. So if a is 12, But yeah, we're not in class, we're going to explain this better, so we'll see. 12 squared plus 30 squared is c squared. So I'm going to go to my trusty Desmos Calculator, and just bear with me because I don't have it open yet, and I gotta fix the window. So I'll go to desmos.com/scientific, and then, all right, can I zoom out a bit? That's good. Okay, so then I have to do, let's see, where am I? Okay, 12 squared plus 30 squared gets me c squared. So the 12 squared is 144. 30 squared is 900. 144 plus 900 is 1044. Square root of 1044 is about 32.3. And that seems reasonable. It's a bit longer than my hypotenuse. So really, I can say, all right, let's see. I can't do all the typing. I'll do it. I'll do it just for you guys. I'll do the color coding. So I'll say 144 plus, hey, get out of here. Get out of here. Okay, 900 equals c squared. Add them together, and I get some big number, 1040. That was weird. 1044 equals c squared. So c would equal the square root of 1044, which is about 30, I already forgot. No, 32.3. All right. And again, this is reasonable. This makes sense because it's the largest side of a triangle and not much larger than the longest leg. Well, you can tell by looking, this diagonal distance doesn't look crazy long. It doesn't look that much longer than my blue dotted line. Like, it's diagonal, so it's a little bit longer, but it's not like a lot longer. Which makes sense, because it's only 32, where the other one was 30. All right. There's my whole answer. Sorry, I was cut off. So basically, yeah, we just used our points to make a right triangle and then did what we've been doing all along. The last exit slip we've had shows that some of you are doing great with this, and some of you are still confused. So please make sure you're coming back to the videos. However, from referring to you might not even be this far in the video right now. So please make sure you're following the process. Have the video open and your Google form. Do not just forget about the video. Follow these steps. Show your work. Okay? So, one more question. What's the entire perimeter of the red, blue, and pink triangle above? Perimeter is total distance around the outside of a shape, so we can just sort of add them together. Red was 12. Blue was 30. Pink was like 32.3. So total, that gives us, let's see, 62.3 plus 12 is 74.3-ish. All right. Just another type of thing. If you have a perimeter question in your Google form, add all your side lengths. All right. I think we're almost done. Yeah, so basically, you can do it even if you only have the ordered pairs as well. Like, think about it, like, so here's our triangle. We have 8, 9, and 3, 2. I can get my vertical side length just by saying 9 minus 2 is 7. And I can get my horizontal side length by saying 8 minus 3 is 5. And then I could just square those, add them to get 74, and then take the square root. All right? But I love the visual approach of the grid. I recommend that, and I think that's a great way to do it. So I'm going to put grids on all your exit slip problems today, and they're going to be pretty quick. So, again, how far apart would J, 4, 5, and K, 7, 6 be? Well, let's make a grid. I'm actually going to go to Geogebra, which is another cool online thing. So J, 4, 5, and 7, 6. Hey, that looks familiar. So let's see, 4, 5, and 7, 6. Perfect, okay. I've already got a J on here somewhere, so I'm just going to take that J and bring it over here. 4, 5, and I got rid of, oh geez, oh dear, okay. Okay. So there's J, and now I need a K on here somewhere, and I got to get rid of the other triangle. 7 comma 6 was it? Can I call you K? Can I rename you? Let's see. I think so. Yeah. Let's see. No. Oh no. I should have done this beforehand. Okay. So this is gonna be point K. Yeah, okay. So now I'm going to go over here, get rid of this guy, get rid of this guy. Okay, cool. Okay, so now we have J, who is at 4 comma 5, and we have K, who is at 7 comma 6, just like we always wanted. All right, just like we wanted in our form. So now we have these 2 points. And again, you can sort of see we could kind of make a triangle going up this street and up here, right? Think about like New York City streets where you're like, oh, okay, we got to go over 3 streets and up 1 avenue to get to our next destination. So you can think about it like that. Or we can just sort of think about the difference in our coordinates. Like if I didn't know where these points were, I could say, all right, well, I was thinking I could stack them on top of each other, but they're, for some reason, I'm not having a whole lot of flexibility movement here. Whatever. So, okay. So we have K equals 7 comma 6 and J equals 4 comma 5. So I can think the difference in the Y values is 1, and the difference in the X values is 3. So let's go back to, that's not what I want to do. Let's go back to this. So the difference in X values is 3. And the difference in Y values is 1. So those are the legs of the right triangle. So I can do 3 squared plus 1 squared equals C squared. 3 squared is 9, 1 squared is 1. So 10 equals C squared. So C equals square root of 10, or 3.1. So I can even do it without even drawing if I want to. You don't have to. But I could also just say, all right, cool, here's my shapes. And if we were in school, I'd teach how to use Geogebra because it's super cool. There's my horizontal side length of 3. Here's my vertical side length of 1. And there's my diagonal side length. So my leg here is 3. Oops. My other leg is 1. So I have 3 squared plus 1 squared gets me C squared. So hopefully that sort of helps you visualize it and like also be aware of the coordinate grid helps you to count and also helps you to sort of keep track of what things look like. And that you can do it without the grid, but you really do not have to. That's it for today. Again, have this stuff open in front of you when you take your form, okay? Do not just do it by blind memory. All right? Enjoy your day and have a good weekend.